Hi dears, this is Raji. We are learning how to express the concentration of the solution in terms of molarity and molality. We have done number of problems related to that, and also we learned what's the difference between molarity and molality also. But for your exams, you will be getting questions like how to convert molarity into molality. If molality is given in the problem, how can it be converted into molarity? That's more important. You should have a clear idea about that. So in this video, we are going to learn about the conversion problems. Also, we will be learning a shortcut method to solve this kind of problems in competitive exams also. So let's start with conversion problems. See this question. Density of 3 molar sodium chloride is 1.25 gram per ml. Calculate the molality of the solution. This is an NCERT question only. Here, molarity of the solution is given. You will have to convert it into molality. So first of all, write what is molality. See, to calculate the molality, we need number of moles of the solute also as well as the mass of the solvent also. Is there any way to find out the number of moles of the solute from this? Yes, they are telling that the solution is 3 molar. What do you mean by 3 molar solution? Yeah, 3 moles of the solute are present in 1 liter of solution. Okay, yeah, that is the meaning of 3 molar solution, right? Yeah. So we got the number of moles from this. Okay, yeah, you can write over here number of moles is equal to 3 mole. Okay, so that work is over. Now we will have to find out the mass of the solvent. See, here we have the volume of the solution. They have given the density of the solution also. Write it. Density is equal to mass of the solution divided by volume of the solution. From this, we can find out the mass of the solution. Mass of the solution will be equal to density into volume. Substitute the value. That will be equal to, what is the value of density? 1.25 gram per ml we have written into, what is the volume of the solution? They are telling that the volume of the solution is 1 liter. So that 1 liter solution can be written as 1000 ml. Okay, so that this ml will be cancelling and you will be getting the mass as 1250 gram. Correct? But remember, 1250 gram is the mass of the solution, not the solvent. Okay, so you can write this one as mass of the solute plus mass of solvent. That will be equal to 1250 gram. Agreed? Yeah. Yeah. From this, if you could find out the mass of the solute, we can subtract it and then we will be getting the mass of the solvent. Now think about, is there any way to calculate the mass of the solute? Yes, it is possible. We have a shortcut method. Number of moles of the solute will be equal to mass of the solute divided by molar mass. Correct, no? Mass of the solute can be written as number of moles of the solute into molar mass. Right, no? Number of moles of the solute, we have already written it. That is 3 mole. 3 into, what's the molar mass of sodium chloride? Sodium will be 23. Yeah, chlorine will be 35.5. So if you are adding together, you will be getting 58.5 gram per mole. Okay, so we got the molar mass of sodium chloride also. Substitute the value. 3 moles into 58.5 gram per mole. Okay, yeah, so mole will be cancelled and you will be getting the answer in gram. If you are calculating this, you will be getting the answer as 175.5 gram. Okay, so you got the mass of the solute also. From this, is it possible to calculate the mass of the solvent? Yes, do that. Mass of solvent will be equal to 1250 gram minus, what's the mass of the solute? That will be 175.5 gram. So you will be getting the answer as 1074.5 gram. Okay, now you can calculate molality. We got the number of moles of the solute and the mass of the solvent also. Substitute the value. 3 moles divided by mass of the solvent should be in kilogram. So we are dividing it by 1000. 1.0745 kilogram. We can write like that. If you are calculating this one, you will be getting the answer as 2.79 molal. Okay, that will be the answer. Problem is little bit lengthy, but for your board exam, if you are getting this kind of a question, it will be for either 2 or 3 mark question. So you will have to show all this working. Got it? Yes. Now read this question. Almost similar to that of the previous question, but slightly different one. It was asked in 2007 CBSE board paper also. Read and find out. An antifreeze solution is prepared from 222.6 gram of ethylene glycol and 200 gram of water. Calculate the molality of the solution. If the density of the solution is 1.072 gram per ml, then what shall be the molarity of the solution? Okay. How to solve this problem? First, we will have to find out the molality of the solution. So, what we will do? Right? What is molality? See, to calculate molality, we need number of moles of the solute as well as mass of the solvent in kilogram also. See, mass of the solvent is given already, that is 200 gram of water. That should be in kilogram. So, we can write that already. What is the mass of the solvent? That will be equal to 200 divided by 1000. Okay, yeah. So, we got the mass of the solvent. Now, how to calculate the number of moles of the solute? For that, they have given the mass of ethylene glycol. Yeah, if you could calculate the molar mass of ethylene glycol, we can find out the number of moles. What is the shortcut formula to calculate number of moles? Given mass divided by molar mass. Okay. What is a given mass? That will be equal to 222.6 gram. Now, calculate the molar mass of ethylene glycol. So, the same formula can also be written as C2H6O2. Correct? Total number of carbon, hydrogen and oxygen atom we have written. What will be the molar mass of one carbon atom? That will be 12 gram per mole. Only for one carbon. For hydrogen, it will be 1. Oxygen, it will be 16 gram per mole. Okay. Now, two carbon atoms are there. So, carbon will be together 24. Hydrogen will be 6. And that of oxygen will be 16 into 2. That will be equal to 32. Correct? Yeah. If you are calculating everything together, yeah, you will be getting the value as 62 gram per mole. Okay. Yeah. Now, substitute the value over here. 222.6 gram divided by 62 gram per mole. Gram will be cancelled and you will be getting the answer as 3.59 mole. Agreed? So, we got the number of moles of ethylene glycol. Now, we can substitute this value over here to find out the molality. 3.59 mole divided by 0.200 kilogram of the solvent. That will be equal to 17.95 molal. This will be the molality of the given solution. Easy. Now, the problem is not over. They are asking you to find out the molarity of the solution also. Right? Yeah. So, what is molarity of the solution? Write and find out. See, to calculate molarity, we need number of moles of the solute as well as volume of the solution in liter. Number of moles of the solute we have calculated already. The solution contains 3.59 mole of ethylene glycol. So, you can substitute the value directly. Okay, that will be equal to 3.59 mole divided by. Now, we need the volume of the solution. How to calculate it? For that, they have given the density of the solution. Okay, yeah. So, how volume and density is related? Density is equal to mass of the solution divided by volume of the solution. From here, we can calculate volume of the solution. Volume will be equal to mass divided by density. here m is the mass of the solution. Okay, so mass of the solution will be equal to mass of the solute, correct, plus mass of the solvent, right? Yeah. So they have given the mass of the solvent, that will be 200 gram, correct? No? Yeah, see over here the solution contain 200 gram of water they are telling, and they have given the mass of the solute also. If you are adding this together, you will be getting 422.6 gram, correct? Yes. So we got the mass of the solution. From this, is it possible to calculate the volume of the solution? Yes. Do that. Volume will be equal to mass of the solution, that is 422.6 gram divided by density of the solution is given, that is 1.072 gram per ml, right? Yeah. Then now gram will be cancelling and you will be getting the answer in milliliter, that will be equal to 394.22 milliliter. Agreed? Yeah. But here to find out the molarity, volume of the solution should be in liter. So we will divide this volume by 1000 and write. Okay. Now write it. That will be equal to 394.22 divided by 1000 liter. Correct? No? Yeah. You will be getting the answer as 9.11 molar. Okay, that will be the molarity of the solution. So we have calculated the molality also, molarity also. The problem is little lengthy, but there is no other way. We will have to write each and every step and calculate. Then only we will be getting full marks. But when you are answering this kind of questions for competitive exams, yeah, we don't have this much time, right? That time we have a shortcut method to convert molality into molarity, right? I'll show you a shortcut formula for that. See, this is the shortcut formula for that. Density of the solution will be equal to molarity of the solution into 1 divided by molality plus molar mass of the solute divided by 1000. Okay, you can memorize this expression. Yeah, for some children it will be difficult to by heart it. They will have to know how we are getting this. For them, yeah, I have written everything clearly. So how did we reach at the expression starting from molarity? So if you are just going through that, yeah, you only can derive it by yourself and reach this expression finally. Okay, I have never seen a question asking derive an expression to show the relationship between molality and molarity. But they will ask you what is the relationship between molality and molarity. You will have to remember this one for doing the calculations, right? Yes. Now see this question. Using our same shortcut method which we were discussing in the previous page, we are going to solve this problem. Read and find out density of a 2.05 molar solution of acetic acid in water is 1.02 gram per ml. What will be the molality of the solution they are asking? See this one. Yeah, remember in this expression density is in gram per ml. Molarity will be in moles per liter. Molality will be in moles per kg. And molar mass of the solute will be in gram per mole. So you can just substitute the value. You don't have to do any conversion for units. Okay, you can remember that also. So in this problem, we will have to find out molality. So let's rearrange before substituting that. Okay. This can also be written as 1 divided by molality plus molar mass of the solute divided by 1000. That will be equal to density divided by molarity. Okay. If so, 1 divided by molality will be equal to density divided by molarity minus molar mass of the solute divided by 1000. Agreed? Yeah. Now, this can also be written as 1000 into D minus molarity into molar mass of the solute. Okay. Yeah, the whole divided by 1000 into M. Right? Yeah. In the denominator, this will be the molarity. Okay. Now, we need molality M. So, reverse the entire expression. That will be equal to 1000 M divided by 1000 into D. minus molarity into molar mass of the solute. That's it. If you could memorize this expression also, you can do the calculations much faster. Okay, now we are going to substitute the values in this expression. So it's going to be so easy. So what is molality? That will be equal to 1000 into molarity. What is a given molarity? That is 2.05 molar divided by 1000 into density. What is a given value of density? That is already in gram per ml. We are not doing any conversion for that. 1.02. Yeah, minus molarity again 2.05 into what is the molar mass of acetic acid? Calculate and find out. Acetic acid is CH3COOH, right? This is the molecular formula. 2 carbon atoms are there. 1 carbon is 12 unit, right? Yeah, so together it will become 24 plus. Yeah, 2 oxygen atoms are there. 1 oxygen is 16, so 2 will be 32. Along with that, 4 hydrogen atoms also will be there. 1 hydrogen is 1 unit only. So if you are calculating everything together, you will be getting 60. Okay. So 60 gram per mole will be the molar mass of acetic acid. Substitute that also over here. Yes. So this will be equal to 2050 divided by 1020. 2.05 into 60 will be equal to 123. Okay, so that will be equal to 2050 divided by 897. Okay, so you will be getting the answer as 2.28 mole per kg. Right now, that is 2.28 molal. Right, what's the answer? The answer is the third one. Okay. So try to memorize this expression, and also directly how can we calculate molality? This also you can memorize. If so, lot of time you can save. Got it? Is it easy? Yes. Now see another question. The expression relating molarity of a solution with its molality will be. See the options also, they are asking molality directly. So in the previous page, see now only we have written this one, right? Yeah. So try to recollect. Molality will be equal to 1000 into molarity divided by 1000 into density minus again molarity into molar mass of the solute we were writing. Correct? No? Here the molar mass of the solute is taken as MB, right? So which is the correct expression? That will be the second one. Easy. We could answer that also. Now see this question. Using our same shortcut method, you can easily find out the answer. You can try this by yourself. I'll be sharing a link in the description box. Yeah, if you're clicking that, you will be getting the answer to this question. Okay. Hope you might have understood the concept very well. See you in the next video. Till then, bye.